Okay, we're now going to take a look at solving rational inequalities. So, for the most part, we're going to find some critical points. Critical points are what we get when we solve the equivalent equation and what causes the bottom to be zero. We're going to put those critical points on our number line and then check to see which region or regions work. So here are our steps. We're going to start out by solving the equivalent equation. So I'm going to put an equal sign in there. I'm also going to make note of what would cause the bottom to be 0. In this case, what would cause the bottom to be 0 is 0. So that's going to be a critical point. Look at my common denominator and solve it just like I was doing with rational equations. And that's a 9s, so I need to multiply each fraction by a special form of 1. This one needs a 3 in the bottom and a 3 in the top. This one already has 9s, my LCD, so I don't need to do anything here. Over here, I need a 3s in the bottom. I need a 3s on the top. So write this as one big fraction, multiply the top, multiply the bottom. One fraction here. Right-hand side, multiply the tops, multiply the bottoms. Once again, when all the bottoms are the same, you can drop them, work with just the tops. And we get a 5 equals 6s, so we get s to be 5 over 6. So that's our second critical point. So I'm going to take my critical point of 0, because that's what caused the bottom to be 0. I'm going to take my critical point of 5 over 6, because that's what I get when I solve it. And I'm going to put those on my number line. So I have my two critical points of 0 and 5 over 6. I now need to go ahead and try a number in each one of the regions. So if I try a number to the left of 0, like -1, I need to plug that into the original. Plug a -1 here for s, a -1 here for s. I get -1/3 plus a -2/9 is a negative plus a negative, which is another negative. Is that going to be less than +2/3? And yes, so I'm going to be shading over there. Then I could try a number in between. I don't know for sure what to try. I'm going to try maybe 1/3. Well, 1/3 times 3 is 1. 1 over 1 is 1. 1/3 times 9 is 3. So I'd have 2 over 3. So I'd have 1 plus 2/3. Is that less than 2/3? No. So I tried a number in between. It did not work, so I'm not going to shade. Then I could try a number to the right. I could try like 1, because 1 is greater than 5/6. So then I get a 1/3 plus a 2/9. Is that less than 2/3? Yes. So I tried a number over here. It works, so I'm going to shade. After I have it graphed on my number line, then I'm going to write my answer. I have two totally separate regions that work, so I need to write two totally separate inequalities. So what's to the left of 0? What's to the right of 5 over 6? And I'm going to join it with an OR statement. So this would be my answer. Now I'm going to just go ahead and do it on this one here. So you go ahead and try to do this one by yourself, and then watch the video to see if you agree. Write your equivalent equation. Figure out that you can't use 0, so that's a critical point. Find your least common denominator, which is 5x. Multiply by special forms of 1 to get that common denominator. Multiply your fractions together. That one stays the same. Multiply these two. Once you have all the denominators being the same, you can drop the denominators. You get 8 on the left, and so you divide by 2, you get 4. So your critical points are what you get from the dividing by 0, which was 0 for our original problem, and what we had of 4 when we solved it. We put those on our number line, and then once again, you need to try a number in each region into your original. We could try like -1, because that's the left of 0. Try -1 here. You get a -1 plus, put a -1 here. So you get -1 plus a -3/5. A negative plus a negative is even more negative. Is that greater than a positive? No. So you're not going to shade over here. You could try a number in between, like 1, because that's between 0 and 4. Plug in 1 here. 1 over 1 is 1. Plug in 1 here. You get 3/5 is 1 plus 3/5 greater than 2/5. Well, yes, it is. So you're going to shade there because it worked. Then you try a number to the right of 4, like 5. So you get a 1/5 here plus a 3 over 25 here. Is that greater than 2/5? No, it's not, so you're not going to shade. So you're only shading in between. We have one region that's shaded, so we can write that as one compound inequality. 0 is less than x is less than 4.